Namaste everyone, welcome to this session of Indic Studies Toronto. Today our topic is who invented calculus, Newton, Leibniz or Indian mathematicians. Our speaker today is Dr. Ashok Kumar Tiwari, who is an electrical engineer by profession and a member of many national and international professional bodies in electrical engineering. He has deep interest in Indic studies and mathematics in particular. Welcome, Dr. Ashok. Please continue.
Thank you, sir. Thank you very much, Indic Studies Toronto, for giving me opportunity to participate in this talk. So today, the topic for the discussion is who invented calculus, Newton, Leibniz, or Indian mathematicians. So all we know that the calculus is a branch of mathematics which is frequently and most commonly used in science, particularly in physics and chemistry, in engineering, all the branches of engineering. And from the past 10 or 20 years, we have found that the application of calculus has been widely increases in the area of social sciences, such as economics, sociology, and many other branches of the knowledge. The calculus is being used. We cannot think that the progress of science and technology can happen without the use of calculus. It is generally believed that the calculus was invented by 16th century British physicist Newton and a German mathematician Leibniz. But in my study, I will show you 1,000 years before the Newton and Leibniz, the calculus were frequently used in India by Indian mathematicians such as Bhaskaracharya, Wilhelm, and so on. There is a long series of the mathematicians in India who used the calculus in ancient time. So, okay. So let me come into presentation mode. Is this presentation is visible to all?
Yes,
okay.
Dr. Ashok, yeah.
Okay. So it is believed that Sir Isaac Newton was an British scientist. He was a physicist and mathematician. He was also chairman of the Royal Society of Scientists of England. He invented calculus. At the same time, a German mathematician, Gottfried Wilhelm Leibniz, he was also called the independent inventor of the calculus in the same period, in the same year. So first thing, this is not a very logically accepted things that two persons, one in England, another person in German, they invented the same type of knowledge, all same formulas, all same theorems of the calculus at the same year, at the same time. So first, this thing is doubtful. So both men published their researches in the year 1680s. Leibniz in 1684, he published some formulas of the calculus, and later on in 1687, Newton published some of the researches in calculus. And it is also very interesting fact that Newton made allegation on Leibniz that Leibniz has stolen his work. And at the same year, Leibniz also made allegation on Newton that Newton stole his work. But both the scientists, they note that the calculus is not the original work of neither Newton nor the Leibniz. They have borrowed this calculus and all the theorem of calculus from Italian mathematicians. We will see from which Italian mathematicians they have stolen their work and how the knowledge of the Indian mathematician reached to Italy and to Roman mathematician, how they came across the calculus. I will show in the next slides. So normally the invention of calculus goes on the backs in dates 1680, means we can say in 17th century. But in India, the first evidence of use of calculus comes in the 6th century AD. And up to 9th century AD, the calculus was very, very developed in India. And it goes to the heights of the human intelligence during the 12th and 13th century. So hundreds of the years before the Newton, or we can say exactly 1000 years before the Newton, the calculus was used in India by the eminent Indian scholars and mathematicians. Now in this slide, we see this is the Newton's book of calculus. Newton's book of calculus. The name of the book was Method of Fluxion and Infinite Series. Methods of Fluxion. Normally, people may think that since Newton is a British scientist, he wrote the book of calculus in English language. But this is not the fact. Newton wrote this book in Italian language. This book was translated from the Latin. Latin was the old Italian. Modern day Italian is different. And the classical Italian, which is a Latin language, was the different language those times. So Newton did not wrote the book in English language. He wrote the book in Latin. And later on, the book of calculus is translated from Latin to English by some other scholars. So the name of the book was Method of Fluxion. This is Newton's book of calculus. In this whole book, Newton did not mention the word differential calculus. He did not mention the word integration. He did not mention the word derivative. So in place of differential of a function, in place of the derivative of function, he mentioned the word fluxion of a function, fluxion. We will see how the Sanskrit falach becomes the fluxion in Newton's work. So this is also one more interesting thing, that Newton did not use the word derivative or differentiation. He used the word fluxion. And Newton wrote this book in Italian language, not in English language, which is in later era, in some during Newton's time, in some of the after some of the years, this book was translated from Italian language to English language. Now there was a war of the calculus between Newton and Leibniz. Newton continuously made allegation in Royal Society that Leibniz has stolen my work of calculus. And Leibniz wrote the letter to the Royal Society principals and the chairpersons that the Newton has stolen my work of the calculus. But both the scientists, maybe Newton and Leibniz, they know very well that this is not the original work of their own self. They have borrowed the work from Italian mathematicians. One Italian traveler is famous in history books. His name was Marco Polo. Marco Polo was a resident of Venice. Venice is a famous city in Italy. So Marco Polo was the resident of Venice. He was a traveler. He made the journey from Italy to Mediterranean Sea. From Mediterranean Sea, he went Iran. From Iran, he went China. And after returning from the China, he came to India. And he spent few years in South India and also in some part of the Gujarat. But mostly, his stay in India, that happens in Kerala and the Malabar coast cities. So this is the route of the Marco Polo, an Italian traveler who traveled in India in 1295 AD. Here we can see the Marco Polo's travel route. So when Marco Polo stayed in India in 1295, he came across some Italian missionaries, some padris, some priests. He also visited some church in India. And those padris, those priests, they handed over some old texts in Sanskrit, some mathematical books in India, some paintings, and some stolen sculptures of India. So Marco Polo taken all this material, he loaded on his ship, and he came to Rome and presented all these gifts to his king, emperor of the Rome. There is a museum in Venice. Venice is a city in Italy, and there is a museum in Venice. The name of the museum is Museum Archaeological. Now, this is a very big museum, and in this museum, the room number 12 and 13 are filled with the Roman arts. So many paintings are there. And this museum, since 2 blocks are completely dedicated on the ancient paintings, there are some paintings which is brought by the Marco Polo to Italy, and those paintings are still available in this museum, the Indian paintings which is brought by the Marco Polo. In one painting, it is shown that how the Indian cities are rich. The richness of the Indian cities is explained in one of the paintings. The very developed port, the very rich persons, very tall and very big buildings of the India, and very rich Indian merchants, they are shown in one painting. There are some sculptures, some statues, which is stolen by the Marco Polo and other Italian. These are also kept in that museum in the Venice. So these, in this diagram, you can see one of the painting which is brought by the Marco Polo, giving the picture of an Indian port. And there are some also metallic statues which is brought by the Marco Polo and kept in the museum of the Venice. I want to stress on 2 important paintings in the museum. One painting which you can see on our left side. In this painting, one king is sitting on the chair and another person who is sitting on the floor and presenting one book to the king. There is something written below this painting. This is written in the Roman language, or we can say it is written in Latin language, in Roman language. The translation in English says that the meaning of this text is Marco Polo is presenting Indian book on calculus to the Holy Roman Emperor Henry VII. So Henry VII was the Roman emperor during the time of the Marco Polo, and there was a very vast acceptance and welcome of the Indian books of knowledge in the Rome. So Marco Polo is presenting Indian books of calculus. It is mentioned very clear, calculus, not the mathematics. Indian books on calculus. This book is presenting the Marco Polo to the Roman Emperor Henry VII. So those days, the kings of the Rome are fond of the Indian knowledge. They appreciate the Indian knowledge, and they keeps and they collect the books from the India in their records. So this was the respect towards the Indian knowledge by the kings of the Rome during those times. In another painting in the same section, section 9 to 12 of the Museum of the Venice, in same section, there is another painting in which one king is giving one book to some person, and it is written behind the painting is written in the Italian language. The translation is that Holy Roman Emperor Ferdinand I giving the book of Indian calculus to Bonaventura Francesco Cavallari, 1634. So in this another painting, the Roman king it is a different king than the Marco Polo, because Marco Polo is a person of the 13th century, and they are talking about this in this painting. They are talking about the 17th century. So king is emperor is different, and this different emperor is giving book of Indian calculus to Cavallari. In later slide, we will see who was the Cavallari and how he used these Indian books of the calculus, which he received by the king of the Rome. There was one person in Italy whose name was Guido Bonatti. Guido Bonatti, who died between the 1296 and 1300. He was an Italian astronomer. And he belongs to some small city in the Italy, which is known as Forli. So in some text, it is also written that Guido Bonatti Forli. He was the most celebrated astrologer in the Europe in the whole century. He wrote many texts, and he also mentioned the books of Indian mathematics brought by the Marco Polo. He wrote that the Marco Polo, when he returns his journey back from the India, he brought many books of the mathematics, and he presented to the Holy Emperor of the Rome. So there are many evidence which shows that the Indian books of mathematics was brought during the 12th and 13th century to Roman Empire. Two Italian mathematicians whose name was Scipione del Ferrero. Another is Girolamo Cardano. Both mathematicians also mentioned that they have studied mathematics from the books brought by the Marco Polo from India. One important mathematician was Niccolo Fonta Targhetta. His city was the Venice, and he wrote a book whose title was Nova Scientineta, means new science. I have mentioned his picture in the right side, and his book Nova Scientia on the right corner. You can see the books written by the Niccolo Fontana Tartaglia. What he wrote in this book was written in the Italian language. The translation is that, in my view, the Indian books of Flexion is the great classical in mathematics, which shows highly intellectual than the Archimedes and the Euclid work, which I translated in Italian. From this sentence, we can find some conclusions, some important conclusion. One conclusion is that this mathematician, Targhetta, this mathematician translated the works of the Archimedes and Euclid in Italian. Obviously, Archimedes and Euclid were the Greek scientists, and whatever they have written in the Greek language. So this person, Targhetta, he translated the work of Archimedes and Euclid from Greek to Italian. Another thing is that he wrote Indian books of flexions. No, he has not mentioned the word calculus. Indian books of flexions. Remember that Newton, who himself take the credit of invention of calculus, he wrote the book Methods of Flexion. And here we can see the Targhetta wrote, in my view, the Indian books of Flexion. So this word flexion is brought to the Newton from the Indian books. This terminology, flexion, comes in picture. We have seen a painting in the Museum of Venice. In this painting, Roman emperor is giving one books of the Indian calculus to the Cavallari. Now, who is Cavallari? Let us come through it. Who was the Cavallari? Bonaventura Francisco Cavallari is his full name. He lived in the year 1598 to 1647. He was an Italian mathematician. Not only mathematician, he was a great physicist. He invented many theorems of the optics, means light. He invented many laws of the motion. His work on the infinitesimal calculus, he also worked on the logarithm, and it is believed that he brought the logarithm to Italy. Cavallari's principle in geometry particularly anticipated integral calculus. So Cavallari was the great mathematician of those times. And the Cavallari's work was studied by the Newton, Leibniz, Pascal, Wallis, Maclaurin, Taylor, and so many other mathematicians, including Fermat in 17th and 18th century. So this Cavallari was the 16th century mathematician of the Italy. He described the principles of optics, which is normally known the principle of optics by the Newtons. So Newton borrowed all the theorems of the light. We know that Newton has discovered many principles in light, such as the Newton's ring and dispersion of the light, and the Newton's theory of the diffraction of the lights. These all the things Newton has borrowed from the Cavallari. Similarly, the laws of motion, the three principles of the laws of motion are mentioned in the Indian Sanskrit text earlier, but the same thing is also mentioned by the Cavallari. And the work of the Cavallaris on the laws of motion, it is also brought by the Newtons from the Cavallari. There is nothing original in the Newton's laws of motion. There is nothing original in the Newton's laws of the optics. In the similar fashion, Newton also learned and the theorems of the calculus from the books of the Cavallari. And the Cavallari got the books of calculus from the Roman emperor, and that was the Indian books of the calculus. So it is clear that the Italian mathematician Cavallari was regarded during those days as a great mathematician scientist of the century, and his work was studied by the Newton, by the Leibniz, Pascal, Wallis, Taylors, Maclaurin, Fermat, and so many scientists of the England and Germany and France. And many of these theorems, which we know in the name of Newton and Leibniz, are nothing but they have taken from the works of the Cavallari. And Cavallari studied the Indian books of calculus. We all know about Fibonacci series, Fibonacci triangle of the numbers. In 12th century, there was one mathematical scholar in the Italy whose name was Leonardo Pisani Bigolo. He has many other names also. His one name was Fibonacci. Since he belongs to the city of Pisa, he was also called Leonardo of Pisa or Leonardo Pisani. His another name was Bonatti. His name was Leonardo Fibonacci. So he has multiple names. He was a mathematician in Pisa. Pisa is the city of the Italy, near to Rome. So this Italian mathematician, he traveled first to Arab. Now, when he reached Arab, he wanted to study the mathematics. During those days, since Arab was nearer to Italy, just crossing the Mediterranean Sea, he can reach the Arab. So in Arabia, he studied the first course of the mathematics. In Arabic, the mathematics is called ilm hindsa. Ilm hindsa means, ilm means knowledge, hindsa means from the Hindus. So ilm hindsa means the knowledge of the Hindus. So in Arab countries, the mathematics is called ilm hindisa, means knowledge of the Hindus. So he studied the subject ilm hindisa there. Then he came across that this is not the knowledge of the Arabian, this is the knowledge of the Hindus. So he wishes that he want to travel from Arabia to India. In some years of the 1200, around the 1200, he came to India. He himself wrote that he visited the Benares, he visited the Prayag and Kashi, where he finds some guru and he studied the mathematics. So this is the book of the mathematics written by Fibonacci. Now in this book, in the cover page, we can see two persons. On the right side person, he resembled to Indian. On the left side, there is a person who resembled Italian person. When we open this book was written in the 1240, means we can say in 13th century, this book was written and printed. So here, when we open the book, we can say some geometrical diagram, some mathematical formula and derivation. So when he traveled Arab and India and learned mathematician, he returns back to Rome. And the emperor of Rome was so happy that he honored him. For example, today, if somebody studied from the Harvard and returned to India, we honored him. Oh, he's a Harvard returned person. He's a very knowledgeable person. He's a Harvard returned person. Now, during those days, in 12th or 13th century, if somebody studied India and returned to Rome, the king welcomed him. Oh, he's an Indian returned person. He has the knowledge of Indians. And the king honored him. King was the king of the Rome. His name was, during those days, Emperor Frederick II. So Emperor Frederick II awarded him. He gave some, he was granting some salary and made him courtier. So this was the status of the knowledge of the India during those days in Europe. So this person, whose name was Fibonacci, he traveled Arabia, he traveled India, and he learned the mathematician. He returned back to Rome and he wrote a book. The book is shown here. Now in this book, if we zoom the front page of this book, you can see here in this front page of this book, there are two persons. So I zoom this photo or diagram on the front page. Here you can clearly see. You can see very clearly that the person sitting on the right side is some Brahmin type of the person wearing the Janeu and having the Shikha. On the left side, there is a Fibonacci. So Fibonacci and his guru is there, the Indian guru. But Fibonacci has not clearly mentioned what is the name of his guru, because it is possible that he studied under many gurus. So he does not mention the name of any single guru there. But it is assumed that either it is a Bhaskaracharya II or this guru was the Brahmagupta, because Fibonacci identity is very similar and copied from the Brahmagupta's book's identity. So Brahmagupta Fibonacci identity is there. So generally we can say either the Bhaskaracharya II was his guru or Brahmagupta, the ancient Indian astronomer and mathematician, was his. So what he wrote in his book, in the preface, he wrote that they are following my introduction as a consequence of marvelous instructions in this art to the 9 digits of the Hindus. He mentioned the Hindus use 9 digit and the 0. During those time, Roman numbers, we know the C, M, X, L, these are the Roman numbers. So they are not concept of any digits. There is no concept of the 0. So Fibonacci introduced the Indian numbers 0 to 9 to Rome and Italy. So he wrote that to the 9 digits of the Hindus, I use the methods of the Hindus. In his book, he used the methods of the Hindus. whose method is called modulus Indo-Turk. The numerals, Indian numerals, in place of Roman letters. Roman person use the letters. For example, C for 100, D for 10, X for 10, and V for 5. We know all the Roman numbers. So they are not aware of the zero and digits. So this Fibonacci, when he returned from the India, he introduced all the digits and zero to the Roman people. This he has mentioned in his book. And what is the cover? What is the diagram on the top cover of the book? We can see here. Fibonacci himself on the left side, and he's taking the knowledge from some Indian guru. This is the, when we open the Fibonacci books, we will find there are some conic sections diagram. There are some diagrams giving the area and the surface. So many mathematical things are there in this book. So all this knowledge he brought from the India to the Rome. Varah Mihir was an Indian mathematician. We know all about the Varah Mihir. Varah Mihir lives in 6th century. Now, in calculation of some mathematical problem, Varah Mihir used the word, Varah Mihir used the calculus theorems. So in expansion of the series, he used the calculus. In computing the rotation of the triangle and the surface area, he used some theorems of the calculus. But at the time of Varah Mihir, the calculus was not the independently developed. It is a part of his Bijganit. It is part of his algebra. In his algebra, he used some theorems, and those theorems uses some concept of the calculus. So we can say the calculus was at the very initial stage or at the very beginning during the time of the Varah Mihir in 6th century. But the origin of calculus started in India from 6th century AD. Up to 9th or 10th century, the calculus was so developed in India. There was a mathematician, Manjula. His treatise was written in 930 AD. Manjula clearly mentioned that the derivative of sine x is the cos x. So Manjula was the first astronomer in India who used the difference of the signs. So sine omega dash minus sine omega is equal to omega dash minus omega cos omega. He used this word where omega dash and omega is very small. So he this omega dash and minus omega he describes as a cheda. He used the word as a cheda, means infinitely small, infinitely small. So Manjula was the astronomer and a mathematician who used the many theorems of the calculus, and he started from the calculus of the many functions such as x, x cube, x power n. He also started the calculus. He uses some theorem of the calculus of the sine, cos, tan, etc. He also used the calculus in the solving the infinite series, and also the finding the correct number pi. He also used the calculus in many other applications also. So up to Manjula, the calculus was developed in India. Now Bhaskaracharya II and Aryabhatta II, they also use the formula of the Manjula, the formula of the calculus of Manjula in their books. Bhaskaracharya in Siddhant Shiromani clearly mentioned that del sine theta is equal to cos theta del theta, where del theta is a very small. So the differential formula was used by the Bhaskaracharya in Siddhant Shiromani in 1150 AD. There were certain problems in astronomy. As we know, Indian mathematicians and Indian pundits, they are very keen, they are very sincere about the making the panchang, about the Jyotish, and about the motion of the planets. Now we know that only Indians are there in the world who first divide the Akash in 12 parts called Rashi. So we divide the celestial sphere in 12 parts in ancient time, and every part is called one Rashi. Now, while making the horoscope or while counting the exact period of the Grahan eclipse, Indian astronomers are very much interested in knowing the Tatkalik Gati, instantaneous motion of the planets. So when one planet crosses one Rashi and goes to another Rashi, the exact time period, exact moment must be known for the further calculation. For this purpose, to know the instantaneous motion or Tatkalik Gati of the planets, it cannot be possible without the using the concept of the differential calculus. So the formula for the Tatkalik Gati or instantaneous motion of the planets is also given by the Aryabhat. It is also given by the Brahma Gupta, and all these formulas are based on the differential calculus. So Brahma Gupta writes U dash minus V dash, where U dash, V dash, and W dash are the longitude of certain planets. So difference of the longitude of the planets, they have described as a sine omega dash minus sine omega. So this is the formula of the differential calculus, which they have used to find the instantaneous motion or Tatkalik Gati of the planets. It is very interesting that when taking the difference of the latitude of the sine, they use the table of the cos. They use the table of the cosine while finding the difference of the latitude of the sine angles. So it is also well known that the differentiation of the sine is the cosine, and the differentiation of the cosine is negative of the sine. It is also known to Aryabhatta and Brahmagupta during those times. So when they are calculating the certain angle, the value of the certain angle of the sine by using interpolation formula. So interpolation formula does not give the exact results. So they use the formula of the differential calculus and the infinite difference of the angle of the sine, they have calculated from the table of the cosine, because they well known, they know as well that differential of sine comes in the form of the cosine. Now, there is one chapter regarding Tatkalik Gati, and this chapter of the Tatkalik Gati is called Kal Kolash. Now, what Indian astronomer thought in the 11th or 12th century, that the normal motion of the planet, it is called the Sthul Gati. Sthul Gati is the normal motion of the planet. Now, motion of the planet in some following day, they called Sphut Gati. And the motion, instantaneous motion of the planet during transition from one Rashi to another Rashi, they called Tatkalik Gati or Sukshma Gati. So what the Indian astronomer observed, that the formula of the motion which describes this Sthul Gati is not cannot be followed in calculating the motion of the Sukshma Gati. So for infinitely small motion or for a very short duration of the time, which called is Sukshma Gati, means Chana Gati of the planet, means instantaneous motion of the planet. So the formula of the Sthul Gati will not work in the case of the Sukshma Gati. So for Tatkalik Gati, they used some other formula, and all these formulas belongs to the laws of the motion of the planets based on the differential calculus itself. So Chana, equivalent to the Chana, the small interval of time of the planet is called the Chana. And what they did, they differentiated the velocity. They differentiate the velocity with respect to Chana, and they found the exactly displacement of the planet. So, which according to the Hindus is an infinitely small interval of the time, immeasurably small. And it will be apparent from the above that the Bhaskaracharya did really employ the notion of the infinite small in his definition of the Tatkalik Gati. So this infinite small calculus and this Tatkalik Gati using the formula of the calculus was well known to in Hindu astronomers 1,000 years before the Newton and the Leibniz. So for calculating the area of the surface, Bhaskaracharya II, whose period was the 1150 AD, he described two methods. One of the method is by rotation of the body and taking the limits from one place to another place, means he used the method of the integration. Bhaskaracharya II, he used the method of the integration to find the area of the surfaces. Now, what they wrote in their treatise, as I told earlier, Newton never used the word derivative or differential. He used the word of flexion. Now, some 1,000 years of before the Newton, or some 100 years of the before the Newton, what we wrote, what we are written in Indian text, the flexion of the sign is cos. In Sanskrit, sign is called jya, and cosine is called kojya. So the flexion of the sign is cos, and the flexion of the cos is minus sign. This is also written in ancient Hindu mathematical books. It means d sin x by dx is equal to cos x. Bhaskaracharya also mentioned that the flexion of the square is the twice of that variable. Flexion of the square of the variable is twice of that variable. It means differentiation of the x square, dx square by dx, is 2x. It is also mentioned that. So Indian mathematicians use the word falach in place of derivative in 1150 AD, and Newton used the word flexion. We use the word falach in Sanskrit, flexion in Italian. Newton used the word flexion in place of derivative in 1680 AD. So we can say about 500 years ago, whatever Newton has written in his books of the method of flexion, it is 500 years ago. The same thing has been written in Indian text of the mathematician. Now, from the 12th century to the 16th century, there was a great school which is known as the Kerala School of Astronomy and Mathematician. It goes beyond the human intelligence. The peak of the human intelligence, if you can find, that is in the Kerala School of Astronomy and Mathematicians. It was flourished, it was fully developed during 1300 to 1632 AD. And the same time when the Marco Polo was wandering in the Kerala, to those days, the Kerala School of the Mathematicians and Astronomy was fully developed. So in this school, there was many great mathematicians. It was founded by the Madhava of the Sangam Grama. Madhava was a great Keralite mathematician. His village was the Sangam Grama. So he is named as the Madhava of the Sangam grammar. His disciples, Parmeshwara, Neelkant, Somyaji, Jeshtadev, Achyut, Narayana, Bhartihari, Achyut Panikkar was the great disciple of the great mathematician Madhava. They have written so many books in mathematics. And those books were studied during those days. Some Christian influences also comes in the Kerala, and there was a Christian priest. They were also wandering in Kerala, and these textbooks were also studied by these Roman priests and some church fellows. All the books are written by Sanskrit. Only one work, Yukti Bhasa, that is written in Malayalam, and all other books are written in the Sanskrit itself. So there is a possibility of transmission of all these books, Kerala schools of mathematician, to the Europe. So how this is transmitted from the Kerala to Europe, the link is given in this here. In this slide, the link is given. Those who are who want to be interested in depth going, they can also refer this link. Neelkantha, he made a very good commentary on the Aryabhatta's work, and some derivation given by Aryabhatta in classical styles. He had made the same derivation from the calculus point of view. So Neelkantha was a great scholar of the calculus in India, and he also wrote that the sine difference. He also wrote about the cosine difference. He also used the formulas of the calculus in his work. So there are so many formulae of the calculus was found in the Neelkantha's work. And Achyuta and Neelkantha, they are the disciple of the Kerala schools of the mathematician and disciple of the Madhava. Two British scholars, they have reported in the 2000 that the Newton and Leibniz should not be credited for their original work. Two British researchers, they have recently published a paper that Newton and Leibniz, they are not the original contributor of the calculus, because in 14th century, the calculus was reached in the Europe from India. Similarly, the notation may be different. Obviously, the Sanskrit notation is different than the notation of the used by the Europeans. Notation are the different, but the original formula and the text and the concept and the theory behind it is the same. So one historian, George Georges Joseph of the University of Manchester, he also concluded the research with the Danish Albeda of the University of Exeter. It was expressed verbally, the form of instruction for how to construct a mathematical equation. He also mentioned that all the books written by the Newton and Leibniz are not their original work. It has been borrowed from the India and Italian mathematicians. Now, I want to tell something about the Madhava. There are hundreds of the ancient Indian mathematicians, in which I consider the work of Madhava is the greatest among all these mathematicians. So as I told, there was one village in Kerala. The name of the village was Sangam Grama. So this mathematician Madhava, he belongs to 13th century AD, and his name was termed as the Madhava of the Sangam Grama. He wrote a book, Madhyamanya Prakara, Madhyamanya Prakar. Madhya means middle, Manya means value, Prakaran means text. The title of the book means Mean Value Theorem. Mean Value Theorem. This is the title of the book. Now we know that when nowadays the students read the mathematics book, the mean value theorem, the credit goes to Lagrange and some other mathematical scientists, but it was originally invented by the Madhava. Now this book, Madhyamanya Prakara, this book was translated by Sir Edmund Stone, published by Oxford, and this book was available on net on Bodleian Archives. If you open the website, Bodleian Archive, you will type the Madhava Madhyamanya Prakar, you will get this book. So this was translated by the Sir Edmund Stone in 18th century, and Sir Edmund Stone was a British mathematician, a famous British mathematician who received the royal patronage those time in 18th century. So Madhava has written the book in Sanskrit, but very interesting, Sir Edmund Stone translated this book not from the Sanskrit, but from the Latin or Italian language. So it is a very clear evidence that the Madhava work was well known in Italy during those time, and some Italian has translated the Madhava works in 13th or 14th century or maybe later. And from Madhava's work in Italian language, Sir Edmund Stone has translated it into English. So this is here on left-hand side, you can see the front page of the book. This was published by the Oxford University Press in 18th century. Madhava's Madhyamanya Prakar, a revised text with the interpretation and commentary by Edmund Stone, Sir Edmund Stone. Sir Edmund Stone was the mathematician, British mathematician of the 18th century. Now, I have also shown here some pages of this book. So here you can see various mathematical diagrams of various mathematical formulas, and you can see here the sign of the integration and the symbol of the differentiation, infinite series, and various axes, and the rotation of the diagrams in this book you can find here. Now Madhava's work, whatever he is written in this book, is taught today to mathematical students and is known today as Hermite polynomial, Chebyshev wave polynomial, Lagrange polynomial, Riemann sterilized integral, Bessel's functions, Lagrange's differential equation, Lagrange's polynomial, Rotary's formula, Hankel transforms, Freedom-Holm theorems, Adams' best fourth and Milne's method, Shor's algorithm. We taught in modern mathematics these things. These all things are mentioned in the Madhava's book of the Madhyamanya Prakar. So whatever Madhava has invented, all these things are now taught to us, to our students, to our children, by the names of the Western mathematicians. Everything is mentioned in the Madhava's book, which I told here. French sent during the British rule in India, Dutch, French, Spanish, Germans, many European countries sent their missionaries to India. The aim of the missionaries is to make India civilized. The aim of missionary is to propagate the story of the Jesus Christ and make conversion in India. So by this aim, many missionaries came to India during this time. The French or Catalan Dominican missionary, it was led by the Giordano's Catalani. He was the first European to start conversion in India. So when he was starting his journey from the France, he was having the concept that Indians are illiterate people. We will go there. We will make them civilized. We will make them educate. But when he reached India in Surat in 1320, after his ministry, he shifted his ministry from Gujarat to Kochi in Quilon district in 1323 AD. Now, when he was work in India towards the conversion agenda, he found that Indians are Indians are having very much higher knowledge than the Europeans. So he wrote some letters to the Pope that Indians are not illiterate peoples. Indians having the very vast knowledge. As he was the first bishop in India, he went Calicut, Mangalore, Thane, and Bharuch. He established church there. Later, he came across some Pandits and Brahmins, and he translated many Sanskrit and Malayalam books on mathematics, science, metallurgy, construction, veterinary. He translated many work in Sanskrit language, Malayalam, books on the mathematics, science, metallurgy, books on the various building construction, temple construction, and books on the treatment of the animals. He translated the book. He wrote a book himself. The name of the book is Wonders of the East. You can download and read this book from the internet. I use the site not remembering this time, but this book is available in internet. Wonders of the East, written by Friar, means father, the pastor, Jordanus. So this book was published in London in about 200 or 300 years ago. This book was published from London. Now, what he wrote in this book? Some points. Father Jordanus Cavallari wrote in his book in 1325, Pandits calculated the age of universe in trillions of the years. They use decimals, numerals, and zero, as do trigonometry and calculus, astronomical calculations. And they say that the universe is not only billions, but trillions of the years in the age. So some things is to be important here. Father Jordanus Cavallari used the word calculus. That Pandits knows the age of the universe. Actually, in fact, as per biblical theories, the period of the Adam and Eve, it comes in somehow 5000 BC, and God created universe in 7 days. That happens in some 5000 BC. So from the Adams to Moses to Jesus Jesus Christ, they have a chronology, and they does not found that this earth was created more than 5 or 10,000 years ago. But when he came to India, he met some Pandit, and Pandits tell that the age of this universe is the trillions of the years. And they proved by some calculation of the trigonometry using some calculus and some astronomical calculation, they proved that the age of the universe is trillions of years. So this he has mentioned in his book, which is written in 1325. He has mentioned the word calculus here. Now, he also wrote that there is a lot of evidence of the ancient civilization was global, and I mentioned many were seafaring and using extremely accurate astronomical heliocentric calculation. Heliocentric means sun is the center and all the planets revolves around the sun. Heliocentric calculations for both earth and celestial motion. He also mentioned that Pandits consider the orbit as a elliptical, not as a circular. The orbit of the planets and the orbits of the satellites are the elliptical in nature. He has mentioned here that Pandits believe that the elliptical orbits are there. He also mentioned that the Pandits calculate the precision of the equinoxes. For example, the wobble of the earth axis, the shifting of the earth axis was also known to the Pandits, and Pandits calculate the precision of the equinoxes. This slow changing motion that completes one cycle every 25,920 years, it is exactly as today's calculation. So in his book, Wonders of the East, Father Jordanus has mentioned the calculus. He also mentioned that the Indian scholars, they know that the universe, the age of the universe is trillions of the years. They also know that the precision of the equinoxes. They know about the shifting of the earth axis. They also knows that the heliocentric universe is there, and elliptical motion of the earths and other planets. So to conclude this talk, the development of the calculus started in India since 6th century AD. Indian mathematicians such as Manjula, which we have seen earlier, the Indian mathematicians were using the calculus since 932 AD. Kerala School of Mathematics in 1300 AD has fully developed differential and integral calculus, and they called it method of Falach. Many Indian books on mathematics were translated in Italian and transmitted to Italy by Marco Polo in the year, I think, 1295. Through Italian mathematicians, the calculus, the knowledge of Indian calculus comes to Newton and Leibniz in 1688. So this is the conclusion. The real inventor of the calculus is not the Newton or the Leibniz. The real inventor of the calculus was the Indian mathematicians.
Thank you, Dr. Ashok. That was a very brilliant presentation. You have given us a lot of information from your research of so many years. Now I will open the forum for questions. You can raise your hands and ask your question, and Dr. Ashok will answer them. So Lakshmi ji, please go ahead.
Hari Om, Namaste. Thanks for the wonderful session. My first question
Namaste.
would be, you had mentioned the word Falaksh.
Okay.
Can you give me the reference to that particular word in that text, which is supposed to contain that particular word? I assume that Falaksh is a compound word.
Yeah.
So text doesn't
Actually,
come.
okay,
Yeah, can
okay.
you?
I tell you, it was mentioned in Bhaskaracharya's treatise. If you go the 12th or 13th chapter of the Bhaskaracharya treatise, he used the word falach, a different type of the knowledge he mentioned there. He told that the falach of jya is kojya, means falach of the sign is cosine. So we know that what is to sine and cosine is nothing but the differentiation. Differentiation of sine is cosine. In another shloka, just after that, he mentioned that the falach of any square of any variable is twice of that variable. So falach of the x square is 2x. So by this way, he mentioned the falach. So in place of the word derivative, the Bhaskaracharya used the word falakcha. And the word same falakcha was also mentioned in the treatise of the Manjula as well as in the treatise of the Madhva. Madhva also mentioned the word falakcha. So for derivative, the Sanskrit word is the falakcha. And Newton also mentioned the word flexion in place of falakcha. Newton also mentioned the word flexion. Newton did not mention the word derivative or differentiation. So by this way, the word falakcha came. Some a terminology is there, terminology for the derivative.
Vivekji, please go ahead.
Namaste, sir. I'm
Namaste.
Advocate Vivek Garg, and I'm learning the Indian astronomy from Sanskrit, Maharshi Panini Sanskrit Vishwavidyalaya, Ujjain. So I just want to ask you one thing. Hello.
Yeah. Yes. Please ask.
I'm audible? Yeah.
Yes,
Sir,
yes. Please ask. Okay.
As far as the Newton's law of motion is concerned, it is also given by some Indian mathematician or
Yes. I think there are three laws of the motion, and it is given in I think Parashar Smriti or Parashar Sanhita. The exactly three laws of motion in Sanskrit are given in the same sequence as the Newton has proposed. So either it was mentioned in Parashar Sanhita, not mentioned in Katyan Sanhita. In some Parashar Sanhita, it is mentioned. The three laws of the motion exactly same. Because it is said that the Parashar has wrote a book on aerodynamics or Vaimanik Shastra. No, sorry, Bharadwaj. Bharadwaj has written the book on the Vaimanik Shastra. So, in the first chapter of Vaimanik Shastra, he quoted the works of the Parashar of the laws of motion, in which the three formulas are mentioned. So, same thing is also found in the Bharadwaja's Vaimanik Shastra. So, these laws of motion are also not the invention of the Newton, it was invention of the Indian seers or sages.
S. Shankarji, please go ahead.
Yeah, Mr. Shankarji.
Good evening. I am speaking to you from India. I am speaking to you from the city of Kolkata. Thank you for your presentation. It had some very important facts, which I became acquainted with. Now, my question is, are you aware of the work of Professor Chandrakant Raju? I am deeply influenced by his work, some of which you mentioned. And, you know, this concept of limit in calculus that is being taught in India and around the world. And he has a very strong point when he says the concept of limit as it is being taught today as part of calculus is because of an improper understanding of zero by the West.
Yes.
So my question is, do you agree with Professor Chandrakant Raju that Europeans and the Western world has an improper understanding of zero? Thank you.
Yes. Thank you, sir. This is a very nice question. Although I have not studied the work of the Professor Raju, but I am very confident that the concept of zero was not very much understood by the Western scholars. For example, the zero, first appearance of zero, it comes in the Sankhya Darshana or Sankhya Karika. Now in Sankhya, they have mentioned that the Purush, he is beyond the cause and effect. And the Prakriti has 25 gunas. And this 25th gun is nothingness. So being nothingness is the 25th gun of the Prakriti. Okay. So here zero was mentioned as the 25th or gun of the Prakriti, means nothingness. Now, in Buddhist philosophy, in Shunyavad of the Nagarjuna, in Shunyavad, they have given a very vast treatment about the concept of the zero. So zero is a macro element. A zero is also a part of the, we can say, the universe evolves from the shunya, and after a certain cycle, universe dissolved in the shunya. So shunya is not the exactly not the zero as Western scholar mentioned in the books of mathematics. Zero has a very good philosophy, or zeroism. Zeroism in Shunyavad. Shunyavad was further developed by the Buddhist philosophers. So I am fully agree that the concept of zero is not very well understood by the Western scholars and the Western mathematicians and the Western scientists. I want to mention one more thing. This Shankaracharya of the Puri, who wrote the book of the Vedic mathematics, who wrote the first book of the Vedic mathematics, Shankaracharya of the Puri, Swami Niranjan Tirtha. He also wrote one book. The title of the book was The Philosophy of Mathematics. In this book of the Philosophy of Mathematics, he mentioned a separate chapter, a full chapter on the concept of zero, how zero is present inside our consciousness, how zero is present in all the elemental form, how the zero is present in the Mahat. Mahat means a macro form of the element. So he has mentioned a very clear how the concept of zero is a very philosophical term, or Shunyavad, or zeroism. So, as you told, I will go through the work of the Professor Razu, and I will also try to study the work of Professor Razu.
Aditya ji, please go ahead.
Hello. Yeah. Good evening.
Hello, Aditya.
I am Aditya Ray, joining from Colombo, Sri Lanka. But I am actually an Indian, a Bengali from Mumbai. I'm a senior media professional. And I have a very basic question. As we could see the clear chains and evidences of inventing calculus, and even many principles like 3 laws of motions, which were originated in India and much long ago than the Western world found it. What is stopping us, and what are the hindrances for us to claim that and correct the history of these inventions? And next part is there a possibility to start the process, and what are the blocks in that process? So that we could actually take some steps.
First thing is that a very clear evidence was found in ancient text, and there was also very clear evidence which was found that how this ancient Indian knowledge was transmitted to Europe, and how it is stolen by the European scientists and mathematicians. The proper evidences are there. But what happens is, still in India, our education pattern is whatever we can say, it is the British pattern of the education. So whatever text has been written by the British, now the same text is being copied by the Indian textbooks. So there is nothing change in the curriculum of the Indian knowledge in the past 70-30 years. But nowadays, I have found some books. For example, solution of the quadratic equation, plus minus under root, plus minus b, plus minus under root b square minus 4ac divided by 2a, the formula for the quadratic equation. Many books now, they wrote that this is the Bodhayan formula, solved by the Bodhayan formula. So nowadays, a very small changes will occur. Similarly, for the Pythagoras theorem, it is also mentioned that it's the Shulva Sutra theorem. Shulva Sutra theorem given by the Vedic literature. In some books, it is being mentioned. But how to claim that? So how to claim that this is the Indian knowledge, this is the Indian property right, this is not the knowledge of the Newton or Leibniz or Pythagoras. We have to fight this war on the government level. So intellectual property right has a common platform where many countries are member of this forum. And in this forum, the government representative can fight that this is the Indian knowledge, and Pythagoras theorem will be known as a Vedic Shulva Sutra theorem, and laws of motion will known as the Newton's laws of motion will be known as the Bharadwaj, or what I can say. I forget the exact name of the laws of motion. Invention of the battery was not done by the Volta, as it is claimed. It is done by the Rishi Agastya. Agastya Sanhita gave the process of the manufacturing of the electric battery. So there are many claims in this field, and at this forum of the intellectual property rights, our government representative must raise this matter in international forum and make correction at the level of the global level, so that it will appear in text.
Yeah, Sunil Kumarji, please go ahead.
Yeah, am I audible? Yeah.
Yes, Sunil Kumar.
Yeah, I have a very basic question. Is there any, as in fascinating lecture and information, is there any comprehensive book on the subject on how India influenced the West from an Indic perspective? Because we know Europeans and Americans write loads of books detailing.
There is one book written by the Prashant Pol.
Prashant Pol.
This Pol. This book is available in Amazon. It is a book. Recently, it is written. This is a recent book written 2 or 3 years ago. This book is available in English, Hindi, and in Marathi. The title of the book is The Contribution of India, something like that. So you can search in Amazon the books by the Prashant Pol, and this book gives the very good evidence in how the metallurgy, how the physics, chemistry, astronomy, mathematics, chemistry, how the science of the original India reaches to Europe and claimed by the Europeans. It is a very good book.
Arkaji, please go ahead.
Hello.
Yes.
Yes, am I audible?
Yes, you can audible. You can ask. You are audible.
Yes. Apart from the in this season discussed about the various parts of calculus, like differential calculus, derivatives, integrations, different part of integrations. But apart from the calculus, even if we look at the Ved, then we can understand the origin of the Vedic mathematics, which deals with the specific branch of the mathematics, focusing on the what is the shortcut method of the every mathematical operators or every mathematical methods, like the how to do square root, how to do square, and every kind of mathematical operations in a very much shortcut way. So considering the Vedic mathematics, we can also understand that Vedic mathematics is also origin. India is the origin of the Vedic mathematics, or Vedic mathematics is the source or is originated from the India. That's the also another perspective of the mathematics. That's I would like to introduce.
Sure. Actually, what is the question? What is your question? See, first thing is that. Okay. In this talk, I told about I was discussing about the calculus. Now, apart from the calculus, the arithmetic, the Bij Ganitam, the trigonometry, and the astronomy, and many other branches of mathematics was also available by also made available by the Indian mathematicians. So there was no doubt regarding the invention of the geometry or invention of the arithmetic, algebra, and other bunches of mathematics. These are very common in ancient India. So there is no doubt that these are invented in India. But the question arises about the calculus. So I took this topic calculus because calculus is claimed to be invented by the Newton and Leibniz. So I took the topic of the calculus because there is no dispute in other branches of the mathematics which was invented by the Indians. See, Vedic mathematics means how to do the faster calculation, how to do the job, and Shakuntala Devi was one of the example of the learned Vedic mathematics scholar. So what happens in our school curriculum? We start from the Western pattern of the mathematics. We start the teaching children from the Western pattern of the mathematics. While in initial stage, we should start from the Vedic mathematics. Then we should go on the a very good book written by the Bhaskaracharya, Rekha Ganitam. One is very good book written by the Varamir, Bij Ganitam. So Bij Ganitam, Rekha Ganitam, Trikonamiti, these are the ancient book written by the ancient mathematics. I surprised that why we don't teach these mathematics in our school. In place of teaching the Bij Ganit by Bhaskaracharya or Bij Ganit by Varamir, we are teaching the algebra by Hall and Knight and algebra by Titice and some other foreign mathematicians. So we have changed our curriculum as per the British system. Colonial education system is still present in India. That's why we are not teaching Vedic mathematics and the books of the mathematics written by the eminent Indian scholars in our school curriculum. So this must be changed.
Lakshmi ji, please go ahead.
Yeah. Thank you for giving me the second opportunity. Sir, in your speech, you had mentioned that Fibonacci had actually come to India and he had learned it under some Indian guru. That was what you had mentioned.
Yes.
And when he
Yes.
got back to England, he had actually written that particular book, which was published, and you showed us the first page of that also.
Yeah.
So
Yeah.
was that the first published work of Fibonacci? Because my question arises is that if such a work could have been preserved and it could have been published, what happened to the manuscripts that could have accompanied him, based on which he had actually written his work? Because what you had shown was in paper. Right. So any possibility of those particular manuscripts, because that would be one of the very ways where you can actually prove the you can track the movement of the work.
Sure.
So do we have access to that?
There must be some ancient library in Italy. If one can take pain and go there and search the ancient manuscript, certainly we will find the Sanskrit manuscript in the in Rome. So Roman kings have very big Granthagar or Abhilekhagar, record room. Roman king have a very big tradition of recording the and collecting the books from all over the world. So Greek books, Arabian books, and Indian books are available there. The original manuscript one can go and find there. But it is a very big task. Who will do it? Who will sponsor it? And what team will go there and search all the records? What we know is from the books of the Italian mathematicians such as Fibonacci. What he has written in his book, in his first chapter, that I have visited India, I studied India, and after returning in India, Roman king welcomes me, and now I am writing this book. Whatever I have learned in India, I am writing in this book. So he has written in his book, Fibonacci. So Fibonacci certainly not mentioned the name of the manuscript, but it is clear that when he was returning from the India to his own country, he has certain borrowed some books there. So from where these are the books, it is a matter of investigation, and this is the matter of research. Okay.
Dr. Ashok, we have run out of time, so we would like to conclude the session now.
Okay.
Yeah, it must be very late for you also. So if you have any more further questions, you can email to Dr. Ashok directly and he'll be able to answer you. Sure. And thank you very much, Dr. Ashok. That was a wonderful presentation. We'll have to go back and watch the video again. So for all the viewers, we're going to post the recording on our YouTube channel. Please go ahead and watch it over there. And thank you everyone for coming to this session. And thank you again, Dr. Ashok. Dhanyavad.
Thank you, Samir Pandey. Dhanyavad for giving me this opportunity. Thank you all the listeners. Thank you very much. Jai Hind. Vande Mataram.
Vande Mataram. Namaskar.